Cool. I think we're live. Is there anybody in the room?
Yeah, it should be at least some souls in there.
Yeah, somebody's got to give us a wave.
Okay.
Soul people.
Yeah.
Yes, our first soul.
Yeah, let's just wait a few minutes.
Yeah. Are there any talks that you guys really liked? Anything you really liked, Ricardo?
I mean, yeah, like there have been some of them quite interesting. Like, so I'm quite interested in all the Parachains. So Basti's talk was quite interesting. Just like what was the issues that we had before when we were trying to deploy a Parachain, a relay chain with Parachain testnet and all the stuff. So yeah, that was a good one. Yeah, the one from Fred, I agree. Yeah, that was also a good one.
Yeah, I only managed to speed watch a couple because I woke up and most of them were already done. So I managed to watch the replay for Basti's, and yeah, I thought that was pretty interesting, and the ink one as well.
Yeah.
Rap God. Oh, I got him.
Yeah, so Hernando right now, where are you right now?
Yeah, I'm in Toronto,
Canada, no?
Canada. So
Yeah,
6 hours behind.
Yeah, that's why you couldn't catch all the talks.
Yeah,
But,
I wasn't really down to wake up at 6 a.m. Yeah, I was pretty excited with the ink talk. Like, I love how rusty ink looks.
Yeah, I agree. I really like ink. It's becoming like easier and much more robust. Like you can do really cool stuff, and yeah, as you said, it's more Rust, less macros that do all this magic that you don't really understand that much. So
yeah, even though there are like the procedural macros, right?
Yeah, there are macros at the end, but
yeah. It looks really rusty, and yeah, I'm hoping that Substrate in a bit can look like it. I think Guillaume's got a PR up for changing how the macros work, right?
Yeah, I have seen that one. Looks really nice. I think also it's gonna be good because it's gonna be backwards compatible. So yeah, it should not break whatever you're building with the actual version. So that's good. Okay, I think we can wait like 1 more minute and then we can start.
So maybe you can ask like the people that are here, how many of you have built Substrate chains and are looking to connect to Polkadot by becoming a Parachain?
Yeah. So yeah, we will start from the base that at least you have tried a little bit of Substrate because yeah. Oh, okay. Hydra TX.
Okay, cool. Yeah, we've got a couple.
Yeah. Okay, so I think we can start now. Let me share my screen, or
should we do small intros first?
Yeah, I think that's the best.
Yeah, so I'm Hernando. I'm a core developer at Parity. I work on bridges. And like today, I'm going to be the host for the Parachain workshop. So I don't work on Parachain, so I'm going to be asking questions just like you guys. And I'm also going to be like checking the troll box and the ask a question box and sending over any of your questions over to Ricardo.
Yeah. Okay, so I'm Ricardo Rius. I'm a runtime engineer. I'm actually basically building anything related to runtimes. Could be Parachains. At some time, I would really like to go to bridges with something that Hernando is working on. And this time I have been exploring Parachains and working with Parachains. So that's why, I'll walk you through the Parachain workshop. So let's start there. Okay, so already said this part. Now, in this slide, it's just like a general architecture of how Polkadot it's gonna be built. Like right now, we only have Parachains, but at some point we are gonna have Parathreads, and so I'm gonna explain like what are the parts. For example, like all of this section is just one Parachain. Then we have Parathreads that are like kind of different paradigm where you basically pay for the usage of the network. Like you share a Parachain slot, and then you will just pay for the specific time that you are using. And like in general. Also, there's the bridges. So this is like the part where Hernando is working right now. Like could be a bridge to Ethereum or to Bitcoin or hopefully any other blockchain. So validators. From the relay chain, we have like the validators are the main authority network nodes in the network. They will be receiving the POV, which means proof of validity blocks that each parachain will give to these validators. And based on these proof of validity blocks, the validator will just check if the parachain block is valid. Then these validators won't stay all the time with a parachain. They will be switching in kind of random way. So by doing this, you will guarantee that at least it will be much more difficult to attack a specific parachain because you will not know which validator will be the one in charge of that parachain. Then we have the part of the collators. The collators are basically like the validator for the parachain. They are the authority nodes of the parachain. These ones obviously remain on the parachain because they have the specific logic for validating the blocks of the parachain. And these collators also contain, they need to be able to connect to the relay chain. In order to do this, they need to have a relay chain node. Right now, we are using just a full node in there. Hopefully, we will change it to a light client node. And so basically, they have two nodes. They have the collator node that's validating the parachain blocks, and they also have a relay chain node in there.
Why is it important for the collators to connect to the relay chain?
Yeah, so they need to follow always the relay chain in order to, because in Polkadot we have like this security that it's an finality that it's done at the relay chain. So they always need to be connected to the relay chain. And by doing this, they will also be able to put the proof into the relay chain, and this will just finalize the block of the parachain. So they will give this proof to the relay chain validator, and they will be in charge, the relay chain validator will be in charge of analyzing the parachain blocks. So in order to like build a parachain, like the main straightforward way is like to using Cumulus. So Cumulus provides like these interfaces, and it's a way to convert a frame runtime into a parachain runtime. This, for example, Polkadot already expects certain kind of interfaces, and these interfaces are being built by Cumulus. So Cumulus will allow to send and to receive this message through the parachains. The way to convert a runtime, normal frame runtime into a parachain runtime, it's quite easy. It's easy. Let's say you just need to add one line. It's a macro, and at the end of your main runtime, you will just add this line, and this macro will expose and will create a validate function. So this function is the one that will be stored. It will be stored in the relay chain, and it's the one that the relay chain will execute to validate the parachain blocks. So this is the part where I was saying, like, we are gonna be sending some part of some blocks, some information to the validators in order to allow them to just approve and finalize the parachain blocks.
So using the validate block function, this is how like these random like relay chain validators can verify that your chain has gone through its state transition correctly, right?
Yeah, that's correct. So using like basically using like this macro, we will generate this function, and as you said, this function will be used in the relay chain. In the validators will be checking that the parachain it's producing the correct block. So it's changing the state transition in the expected way. And like, what's this proof of validity blocks? These are just blocks that are sent. It's not just a block, but it contains like some extra information in there, like transactions, and all the information here comes in a opaque way. And the reason why it's opaque, it's because Polkadot doesn't really need to know exactly what are all the types and all the exact information that the parachain has. It just needs to read the headers and then use the function of the validation function to check and to create like the part of the try. So by validating the try using just specific part of the blocks, it will be able to finalize the parachain blocks. Now, going to the part of the intercommunication.
Quick question about the POV block. So when the relay chain publishes a block, does it contain like a lot of these like POVs for the different parachains? So does it just like collect all of them and use those as like transactions in a relay chain block?
Yeah, that's correct. It stores many of these POV blocks, but it doesn't store all the block in the relay chain. It will just store the headers, but it will use the POV blocks temporary just to do this validation. And the other thing is Yeah, I mean, that's, the most important part. Yeah. So then we have like this important part, which is the intercommunication, which is a cross-chain message passing protocol. And basically, we have two ways of doing this message passing. So we have the direct way and relay way. The direct way is something that we don't have yet on version 0 of the Polkadot and Cumulus implementation. And this is really what we expect because it's the fastest way, and it's very scalable because it will be, as it says, passing message between different parachains. And the relay, it's using the relay chain in order to pass this information. And this is right now like the way how we are gonna develop our own relay chain with the Parachains. It will be going through the relay chain, and this is not really scalable because then you can saturate the relay chain with a lot of extra information that the relay chain doesn't care. And at some point we will need to remove this part. So in version 1, which we expect to have in a few weeks, no promises when, we should be using the direct, not just the relay one. And in order to send this message, we have basically like 3 types. So we have the vertical message passing, which kind of has 2 types, has the upward message passing and the downward message passing. So the way how it works is, as it says, the upward message passing, it goes directly from the parachain to the relay chain. And then the downward goes from the relay chain to a parachain. So in order, for example, what we will be doing, or what version 0 of this intercommunication is doing, it's going upward and then it's going downward to the other parachain. So it's using the relay version of the intercommunication protocol. And this is why it's not very scalable. And that's how Rococo is working right now. Okay, so I think it's time for the workshop. So the workshop, it's...
Yeah, we should drop those links in the chat.
Okay, that's a good idea. Yeah, I can do that. Let's do that. So let's take pause.
I don't think you sent the Cumulus one.
It was, the Cumulus workshop?
No, so I sent that one, the template, I think.
Oh, okay, let me see. Oh, yeah. I mean, I haven't sent them. I'm just pasting them. And then we have another Parachain example that we are going to be using.
I sent that one already.
Okay. Okay, so, you sent. Nice. Okay, so now.
So which one should people click first to follow along?
So, the first thing that this will take some time because we are going to compile a lot of things. We are going to compile Polkadot and the Parachain template, or in this case, you can, instead of the Parachain template, you can use the NFT Parachain that we shared in the box. So, I think Polkadot, it's a good idea. Like, you can just clone the Polkadot repository, which you will, basically, it's in Parity tech, Polkadot. You clone that repository and then just do a checkout on this specific commit, which will be related to the Rococo branch. Then Substrate Parachain template with the latest commit on the Substrate Parachain template. or you could choose this one. And yeah, Polkadot JS apps, yeah, then this part, I mean, we are gonna use the self-hosted version. So yeah, you don't need to care right now with the Polkadot JS apps. So the important part here is like, first, yeah, compile Polkadot and on this specific commit, and then the Substrate Parachain template. But there's probably gonna, like, if you haven't been building a lot with Substrate lately, you will have some issues probably with the nightly version. So I updated that part of the README. So if you already have Rust installed, which you can follow, for example, in the Substrate Dev Hub, if it's the first time that you have been doing one of these workshops, you can go to substrate.dev, knowledge base, and getting started installation. And yeah, it will tell you what requirements you need to have in your own machine. Then in order to build this specific version 2 of any Substrate-based Parachain, standalone chain, whatever, you need to use nightly version, like this nightly, and also like run this command. And then you will build with Cargo nightly build release. Also, quite important, after you build that part, you need some Polkadot JS types. And this is kind of the important one right now because this recently changed on the main on master, and yeah, you just need to override the existing types with these types. I will show you how to do it also, but just to show you that you have the types there. So yeah, first step, let's just clone and get Polkadot. I already have that part. So I have Polkadot already compiled in my machine at that commit, and then I also have the Parachain template compiled. So let me just explain you a little bit about the workshop. Yeah, this is so also another option if you want to skip like the compiling the Polkadot node. If you have Docker, you can download the Docker images, which we have somewhere.
I think it's at like the very bottom.
Maybe. Okay, yeah. So yeah, if you use this, yeah, you can use a collator here and also the Polkadot version. So using this Docker will also work if you don't want to build Polkadot in your own machine. And then yeah, that's the main thing. Like first, we need to start by just installing all the things.
Ricardo, somebody's asking, should we use the mentioned Parachain commit or the latest one with the added Polkadot JS types?
It's the same. So the only difference right now there is that I updated the README, but nothing in the code changed. So it will be the same if you use the latest one.
But so you should be using like the Polkadot JS types regardless.
Yeah, but the Polkadot JS types are only in the README. I mean, the last update, the last commit was just updating the README, not really changing the code. So yeah, it's the same if you use the latest commit here or the commit that says in the other one on the workshop. That's okay. So now let's explain a little bit about the workshop. Let's start explaining this part. Yeah, building the relay chain is explained here. Also collator, template, how you clone and then build. But yeah, as I said, you are not going to build this way. You are going to need to build with the specific nightly because otherwise it will not compile.
So what's our goal with the workshop? What's like the end result that we're striving for?
Okay, with the workshop, we are going to create a relay chain quite similar to Rococo. And then we are going to connect two different parachains. These two parachains will be able to send native tokens, and also with the NFT parachain that I shared, you will be able to not just transfer from one parachain to another parachain native tokens, you will also transfer NFTs. So yeah, an NFT will go dancing all around the parachain. You can move your Substrate kitty from one parachain to another parachain. That's the main goal, just to show the interoperability of Polkadot. Okay, so yeah, let me go to launching the part of the relay chain. So in order to start all the relay chain, we will, for example, if you want to connect two different two parachains, you need at least 3 relay chain nodes. So I'm gonna start 3 relay chain nodes in my case, but in case that you just want to test with one parachain, you only need 2 relay nodes. So for example, here is how you started with Alice. And then, yeah, also you need to connect to Polkadot JS apps, and also how you start with Bob.
So the reason we need 3 nodes is so that we can have the relay, so one relay chain validator for each parachain, and then one relay chain validator actually producing blocks for the relay chain.
Yeah, the main reason, it's kind of that. So the thing right now with the actual implementation of the Parachains is that they are not even using either Aura or Babe. So yeah, they use another block production mechanism, which it's less reliable in that way. So yeah, you need to have one extra validator in order to guarantee that at some point the block will get into the relay chain. But yeah, in general, you need one more, at least one more. So yeah, the first thing, for example, something that we always do is you need to create your own specific, your Rococo chain spec, and this Rococo chain spec you need to add the validators. In order to do that, yeah, we have some already built for you in the workshop. You can do that here in the chain spec part. So let me explain this part. So here you have, for example, if you are going to connect 2 parachains, we have the Rococo 3. If you want to connect 4 parachains, we have the Rococo 4. You can download these JSON files, and then you will need to use these files in order to connect. Yeah, for both, for the relay chain and also from the parachain. Both need to use the same file, because as I said, the collator also runs a full node of the relay chain. So it also needs to know the exact specifications of the Rococo, and also, yeah, be able to connect to the same chain. That's why we use these JSON files. So yeah, after you created your own JSON files, or yeah, download the ones that we have there, you can launch your relay chain. And in order to launch the relay chain, this is where we are passing the spec version, the Rococo 3 or 4, whatever, which one you chose. And yeah, you can probably right now, you don't care about the boot nodes if you are running everything on your own machine. Same thing if you want to start, like you have Alice, Bob, Charlie, you can start also another node on the same machine. It's what I'm gonna be doing. And yeah, let's start by just doing that part. So the first part is launching the Parachain. So it's the way how I'm gonna do it. As I said, let me just, okay. So I have the Polkadot binary here. I'm specifying the JSON file, custom JSON file. This is just a temporary directory. I'm specifying that it should be validator. The validator will be Alice and just a port. So the first node will be Alice. Then the second one will be same thing, but with Bob, and also changing the port. It also needs to point to a different temporary directory, just because otherwise it will overlap with the other directory if you're using the same machine. And the third one, it's using Charlie.
So right now what we've done is we've launched our relay chain.
Yeah. So we launch our relay chain, and this configuration, for example, has 3 validators. So I'm using the version that says here, yeah, the 3 JSON. So the Rococo JSON file that I'm passing to these ones, it's just the 3 validators version. Now the next step is the part of the Parachain. So the part of the Parachain, yeah, I'm gonna, if you already build the Parachain, then you can basically just start the Parachain collator again with just specifying that it should be a validator, also a port. Then something quite important here is that you need to pass the Parachain ID, and also you need to pass some specific configuration, which is the same file that we are passing to the Rococo, to our relay chain. You need to pass that file to the second node. So how do I know that we have 2 different nodes here? For example, this is just what separates one node from the other one. So the first node is the Parachain collator. It's the which will be validating the Parachain blocks that ends up here. And then after this --, we specify all the parameters that we want to pass to the full node that is connected to the relay chain. And that's why we are passing this.
So when we start a collator, we're starting the collator node, which is what that first set of arguments does. But then we also need to tell the collator, hey, if you want to connect to a specific relay chain, how do you talk to that chain? That's why you need the second set of arguments. So you know that your relay chain node can talk to the right chain.
Yeah, that's correct. You can also pass also ports and different configuration that you can pass to any other node. Yeah, but this is how you tell that you are passing after these dashes, you are passing the parameters to the other node, to the relay chain node. So yeah, then the next thing that we are gonna do is just start this node, I started with the Parachain ID 200. Now I'm gonna start in this case with the Parachain ID 300. So the collators right now, because of the block production that it's using, you can like just start a parachain with one collator. You don't need several collators to validate and to agree into the blocks. And that's why I'm just starting like 2 parachains with only one collator. So the first one is Parachain 200. The second one is Parachain 300. Same thing. It's using the same code. The only thing that it's changing there, it's the ID and also the port, just to prevent the collision in the ports.
So I've noticed that, so in the logs, you can see that relay chain, so it's tracking the relay chain blocks, but it's not producing any parachain blocks yet.
Yeah.
How's that?
That's a really good point. So yeah, none of the parachains are producing blocks right now, but the relay chain is producing blocks. So in order for a parachain to produce blocks, it needs to be registered in the relay chain. And this process of registering a parachain in the relay chain is when we are gonna pass the first header of like the first block, and we are also gonna pass the validation function to the relay chain. So for example, let's do that for the first parachain. So the first parachain, I'm going up here to the log because we will need this genesis state, which is the first block. Head is the header of the first block, and yeah, this is the only thing that we need here from the log. So let's go to Polkadot js.org/apps. And in order to connect to the relay chain, so the relay chain, one of the nodes of the relay chain is, we have 3 nodes of the relay chain. One is running in this port. We can use just the standard port to connect to the relay chain. So as you can see, this is the relay chain that we are running. So for example, block 46 and yeah, block 46. So how do we register these parachains? First, we need to go to extrinsics, and we need to do, in this case, we need to do a pseudo call. That's the only way right now in Rococo. Then with the pseudo call, we are gonna call a palette that it's called register, and we are gonna register a new parachain. So the first thing that it's asking for parachain ID. So we are gonna put 200 there. Then we have the validation code and also the header. So let me just first copy the header, which is the one that was printed here in the log. And let's paste this one down here. And then the validation code is the WASM blob, which already contains the validation function. And I will show you later in the code how this looks like. But right now, let's just take it as granted that Cumulus did this for us. So let's just do this, release, build, Parachain runtime. And this is, so for example, whenever you do a runtime upgrade, you are using the same code. So in this case, it's the same. It's all the WASM blob that already exposes the validation function in there. So let's do the pseudo call.
So
yeah?
What we needed to register is we need the WASM runtime of our chain and this initial head data. And what's contained in that initial head data?
Okay, so this head data contains like the information of the first block, the headers of the first block, and also it's related to the to a Parachain ID. So it's basically an encoded, it's the header of the first block. That's basically what we have here. And these are like headers we'll see later. I can show you that these headers will be getting updated. So these headers are the ones that will be sending the parachain in order for the relay chain to validate. So we need to provide the first header. Then the parachain will do it by itself. Okay, so we need to wait a little bit. Okay, now it succeeded. Let's see if our first parachain is producing blocks. Okay, so looks good. It's now producing blocks. So yeah, now we have one parachain. We can also connect from Polkadot.js to that parachain. That parachain is running on port, in my case, port 47. But I need to add the Polkadot.js types. So you need to go to settings, developer. And in this case, the parachains that I'm running are the NFT parachain. So let me just take all the types that this parachain uses. Should be this one. And let's just refresh this part. Okay. Was it 47? Why you are not connecting?
Are you sure it was the right port?
It was 40, maybe it was 46. Oh, no, it's
45.
Yeah, 45. Okay, let's see if it's not colliding with the other ones. 45, no, should be good. So let me change to 45. Okay, yeah. So it's now working, producing blocks, 13 and almost 12, and it's creating the 13. So yeah, there we have it. Now we can, like any other parachain, any other chain, we can do normal transfers. I'm gonna skip that part, it's boring. But then I'm gonna register the second parachain, and I'm gonna do a cross-chain transfer. So for example, if you see, yeah, again, the second parachain, it's not producing any blocks. So I need to do the same process. And because these two parachains are using the same code, we are gonna use the same block. But the main difference is that the header is different because it starts from a different state, also because of the parachain ID. So the parachain ID is what will be generating this different initial header. So let's connect back to the relay chain. Let's do the same, sudo call register. In this case, it's 300. And then let's just add the same NFT parachain runtime. So we are gonna Looks good. We are gonna
So
do this.
right now we're going through pseudo calls, but for Polkadot, we would be doing this differently, right?
Yeah. So for example, for Rococo, we have two ways right now. One is pseudo call. The other one is through a proposal. And then, yeah, there are some people that can approve the proposal. In case of Polkadot, yeah, it will be different. It will be all these cushion and these kind of automatic, yeah, based on some candle accusation and all that stuff. So now the second parachain is producing blocks. So 3, and we can connect, should be 46. And it looks good, producing blocks. So now let's open, let's see if I can. Oh, not deep. Okay, I want to put the two windows side to side. Let's see if we can switch without changing both. Should be okay. Okay, so now we have the two parachains. The one in the right is 200 and left is 300. Now, let me go back to explain the next part of the workshop. So, as I said, we have like this way to generate like tokens. We already registered, and yeah, that's perfect. So the next part is doing the downward transfer. I can do this like by doing from the relay chain to the parachain. And this is doing a type of, we are calling it a mint model. And the reason why it's a mint model is because all the parachains already trust the relay chain. So the relay chain can, like in this case, the relay chain can generate tokens in the parachains, while a parachain cannot generate tokens for the relay chain, because if you do that, you will be like you can create your own parachain and then create a lot of tokens and then change all your tokens for dots and become rich at that point. And that's basically quite insecure. In the other way, you could be like wrapping your dots and passing them to the parachain. This is the idea of doing the downward message. So in this case, there's just a simple conversion. It will just convert 1-to-1, whatever amount of tokens you pass from the relay chain, it will also mint them in the parachain. Then I'm gonna show this part also. Then we have the opposite case. Once you did this, like if you already created some tokens that came from the relay chain to the parachain, you can send them back to the relay chain. If you haven't done the first step, you cannot pass tokens because, as I said, you will be minting dots or rocks or whatever the main relay chain is named. And then we have the part of the lateral transfer. And this is where we are gonna be transferring from one parachain to the other parachain. In this case, I'm gonna showcase two ways. So one way it's like using the normal balance. And in order to do the normal balance transfer, like using the native token to transfer from one parachain to the other parachain, you will need to have a deposit like in the other parachain. I will show this part. And I'm also gonna show how you can, for example, I'm not gonna do this deposit in case of NFTs because NFT is a unique token. So for transferring an NFT from one parachain to another parachain, I'm just gonna do a simple transfer. I'm just gonna remove the NFT from the owner in Parachain A, and then pass probably to the other owner on Parachain B. So first of all, let's start with showing like from relay chain to the Parachain. Let me see how the time's going. Okay, so I need to kind of hurry up on these parts. Okay, so yeah, let's keep it this way. Let's switch this one to the relay chain and then transfer from relay chain to the Parachain. So on this side, we have Parachain 200, and here is the relay chain. Let's do a transfer. So we are gonna call a specific function, a specific palette here, which is called, it's a Parachains, then transfer to Parachain, and you need to select the Parachain ID, Parachain 200, then also the amount. The amount in this case, let's not send from Alice because Alice, we will be using Alice for more things. Let's send from Dave, and let's send, I don't know, like 500. And in this case, for example, you cannot select the destination account. So it will be like how it's implemented right now. It will be for the same account in the Parachain. So we will be passing more tokens to Dave. So let's just transfer from relay chain to Parachain, and Dave from Dave to Dave. So let's wait.
So what it's doing is we're sending native tokens from the relay chain, and then we're converting them one-to-one to the Parachain tokens, right?
Yes. Yeah, that's precisely what just happened right now. So here they've received more tokens, and you can also like change the conversions. For example, you can see here we have just thousands, and then here we have else. So this was from Dave to Dave. Then we can do the same thing, passing the tokens up back to the relay chain. I can showcase that part from the relay chain. We can also, let's do the same. It's, which one was? I think it's message broke. No. Yeah, token dealer. Token dealer, we will be using it for many things. I will also explain that part of the code. So let's just pass 100 from, in this case, we can choose the other account. So we can pass them to Ferdi on the relay chain. Because these are already tokens that we trust. So you can pass them to anyone in the other chain. Also, you don't need to specify, obviously, any Parachain ID because there's only one simple relay chain. And as you can see, the units are different here. So it's not passing 1-1, but yeah, Ferdi received the tokens. This is probably because of chain decimals. That may be the only difference here. Now, okay, so we transfer down, up, and then let's do the cross parachain transfers. So in order to do that, let's, oh, this is the same one. Okay, so in order to do that part, let's explain that you need to do this pre-funding part. So each parachain, so the way how it's implemented in version 0, because like right now it needs to go through the relay chain, and there's no, the relay chain is the only one that is giving the security. There's no direct communication between parachains. So we need to create a trust model, and this trust model is like each relay chain has its own, each parachain account, each parachain has its own account, and every time that you send a transaction from one parachain to the other parachain, you can detect either the parachain ID or the parachain, or convert it to a parachain account. So by doing this, you will be able to detect and to mint tokens that belong to the other parachain. So what we are going to do is, for example, we are going to take from our parachains, we are going to go up again to the start of the log, or we can stop and start the chain again. Okay, but no, I got it. So this is the parachain account. So for example, this is parachain 200 and this parachain 300. In order to allow this interchain transfer for this native balance, native token, I'm gonna go, classic. Anyway, I'm gonna go to the parachain B, and I'm gonna do a transfer for a specific amount to this address. So this will be like all the amount that parachain A will be able to spend on parachain B. So if at some point parachain A want to do more cross transfers, it will not be allowed because it will like exceed the deposit that I kind of allowed for them to do. So let's do that. Okay, so this is parachain 300. Let's go to accounts. So this will be like is the parachain that we have down here. Let's do a normal transfer. Let's do this deposit. So let's say from Bob stash. So from Bob, we are gonna deposit a certain amount for the other parachain to allow them to do the cross transfer.
So we're making this deposit on our own parachain.
Yeah, so you are like giving permission to spend a specific amount of tokens in your own parachain. So this is just like, version 1 will not be this way, but yeah, right now that's how it's working. So as you can see, the parachain account now can spend some tokens. So let's do that. Let's transfer from parachain 300 to parachain 200 because we already have a deposit in 200. So let's do that part. Extrinsic. Anyone can do this transfer. So let's say Alice do the transfer again, token dealer. And let's use the transfer token to Parachain. So the Parachain will be from 300 to 200. And yeah, let's pass to Alice to Charlie. And the amount will be, let's say, 100. So what's happening right now is we are using the relay chain to pass this message. We are not communicating the two parachains. So it's going up to the relay chain and then it's going down to the relay chain. It's minting in the relay chain. So as you can see, it added different units. Okay, no, it's not possible to see because it was a really small amount. But yeah, it passed to the other parachain.
1,000 unit deposit we put down, has that changed at all?
Yeah, it changed. We can see that bar. Let's see, send. Okay, no, let me see. No, it didn't change in this case, so let's see what just happened here. It should have changed because we are talking about Parachain 200 to Parachain 300. So or I chose, this is 200. Let's try again. Let's check what could be the thing here. So you need to do this, have this transfer. Could be that it was so let's see. Is this 200? Yeah, it should be 45. Yeah, this is 200. So yeah, that was the correct procedure. Okay, I don't know what, but let's just try to increase the amount to transfer. Let's put more. Let's increase the deposit. Oh, all right. This was the issue. It was not the deposit. It was a Parachain ID. So the one in the left is Parachain 300. And I'm sending here. This is one of the things that we are not checking right now in the protocol. For example, I should have chosen here 300 instead of 200. Because you are allowing this Parachain B and this Parachain A. So you're allowing to spend certain amount of tokens in Parachain 300. So we need to send a transfer to Parachain 300. That's why it didn't work. So let's just also increase this amount and try again. So basically what we did is we created a transfer for the same parachain, which probably went up to the relay chain and went down without really doing anything.
Okay, so now we should see like the 2,000, I guess, deposit go down by 1,000.
Yeah, it should. Okay. So we sent to Charlie. Yeah, and Charlie has more tokens. So let's check that part. Oh, really? It didn't change. Ha. Okay. I'm not quite sure why this is not changing, but
You said this model was going to change with V1 anyways, right? So we should just
yeah,
move on instead of spending too much time on it.
I agree. Let's just showcase that, yeah, you can also do this, but with NFTs. Let's see. I tested this, so should be working. Yeah, let's create, just for clarity, let me put A on the left and B on the right. Okay, so let's create a NFT in Parachain A. So let's mint a token. In this case, yeah, just for simplicity, the metadata is any number. So let's just choose 1, 2, 3, 4. And yeah, also the data that goes on the NFT could be whatever. In this case, let's choose 55. And it will be assigned to Alice. Let's just wait until it mints the token.
So right now you're just minting it on Parachain A, and then we'll do the transfer after. And this is something you've included as part of the NFT template, the collator template.
Yeah, that's right, in the Parachain one. It's also a little bit slow because, yeah, it's using a lot of resources for the crowdcast. So it succeeded. Let's just check the tokens that Alice has. So Alice should have token 0. Okay, it has now an NFT. We can check the details that we added for the NFT. So let's just check. I only have one class, which is class 0, and in this case, it's the first NFT, so it's 0. So the owner is Alice, data 55, and the metadata 1, 2, 3, 4. Now we are gonna pass this NFT to the other parachain. And yeah, the only thing that we need to do here is also call our extrinsic token dealer transfer NFT. So it's going from Parachain 200 to Parachain 300. Alice is that could be to Alice or it could be to Bob. Let's send it to Bob. And the token ID, it's 0. We only have one token there. So let's send it. So if this succeeds, there's not gonna be any NFT here. Let's see, let's just validate first. Okay, Alice doesn't have any token. Let's just check that the token doesn't exist. Okay, so let's hope it's here. Now let's check. Yeah, we tokens of Bob. Okay, so Bob has the token. And let's validate that it has the same data, but now the owner is Bob. Yes, so same data, same metadata, and the new owner of the token is Bob. So this was an NFT transfer, and as I said, it went to the relay chain, and then the relay chain passed it downward to the other parachain. Okay, now we concluded the demo. We can explain the code. Yeah, let's go directly to the code. So, for example, this is the NFT parachain that I was showing. And the important part here is in the token dealer. So the token dealer, okay, no, before token dealer, let me just show you how you have your own runtime. So you have like all of these palettes are palettes that work in any standalone Substrate chain. So you don't need to be like building a parachain to make it work. They work in other, in a normal node template. So as I said, you will see that the runtime looks normal, quite similar. Everything looks as usual. We have like all the implementations, then construct runtime. But at the end, in this case, we have this line. This is the macro that it's using. It's the Cumulus macro that is generating the validation function that we were talking about. So this will expose the validation function in our runtime. And that's why.
Does the macro provide anything else aside from just the validate block function?
No. I mean, Cumulus in general creates all of these protocol, but all of the protocol that Cumulus is doing, it's part of the node, part of the service. But most of the thing that this macro generates, it's just the validation function. This is the main goal of this macro. And yeah, as I said, basically the part of the runtime, if this looks familiar to you, yeah, forget these two because these are the temporary folders. For example, we have the runtime folder. So everything inside this runtime folder, it's the same that you have in a standalone chain. The palettes are also the same. The thing that mostly changes is the node part, so the client part. And it's because it starts, as I said, it starts the relay chain full node and also starts the other, the parachain validator. So there's a lot of services that differ from a standalone chain. It's not using Grandpa to finalize the blocks in this case, because Grandpa, it's on the relay chain. So it's just producing blocks, sending the POVs to the relay chain validators, and Grandpa in the relay chain finalizes the blocks. So these are kind of the main difference with the client. Okay, so now that we saw this super magical line, that it's the only thing that changes here, then we can go to see the token dealer and understand a little bit on the part of how it's doing sending the transfers, sending the tokens. So yeah, we have the upward messages. We have just specific handler that this XCMP message sender is the one that will be transferring the message through the relay chain. And so, for example, let's see the easy case, like the NFT. How does the NFT get transferred? So the NFT, you need to pass like what's token ID, account, the Parachain ID, destination. And then what we are going to be doing on this side of the chain is the first part, it's executed on Parachain A. So we are passing from Parachain A to Parachain B. The first part is executed on Parachain A, which is we are removing the token from the owner. And the second part, it's going to be executed in the Parachain B. And this is why we have the send message. So this function, it's executed on two parachains at the same time. So the first part just deletes the NFT, and the second part will be calling. You will be sending to a specific Parachain ID. Then this message, you can define different messages here. For example, this is just an enum. I have two different messages defined there. which is the transfer token. It's the one that transfers normal balances, and the transfer NFT that you need to pass, like just account and the NFT data. Then, going back to this part, then we need to tell, whenever you receive the message, you are gonna, on Parachain B, you are gonna receive the message that it's saying, yeah, we need to execute whatever this message refers to. So you need to have a handler. In order to have that handler is this trade, we have this handler. And here we are like just, yeah, we need to create the two cases. For example, the transfer token, this one is just transferring the normal tokens, the native tokens, and the NFT transfer. The NFT transfer here, it's it's doing the opposite from chain A. So if you're burning chain A, you need to mint on chain B, but you need to pass like the main information. That's why I'm passing the metadata, and also data to the chain. So I'm minting a new token, but with the exact same information that comes from the other parachain. And yeah, it's basically just like that. So what's, again, just to say it simpler, executes this part on this chain, then we send a message, relay chain goes to the other chain, goes downward to the parachain, and the parachain, whenever it receives this message, it executes the logic that we defined here. And that's how we transfer the NFT from one chain to the other chain.
So somebody's asking, does that mean the NFT palette needs to be present on both parachains in the same version?
Yes, that's correct. It needs to be, doesn't need to be the exact same code, or you can have like different implementation of NFT, but you need to be able to like handle the situation. So whenever you receive this message, you will decide what's the NFT, how you are gonna receive the NFT or the tokens. These are just simple message, trustful message that are passing through the relay chain.
So I guess like, could you have different handlers for like different like versions of the NFT palette or something like that?
Yeah, I think you could. Yeah, I don't see why not, but then you will need to also pass like what's the version of the NFT, which you could handle. You can pass those as part of the data or part of the versioning, or I'm not quite sure if the version 1 or the next version of XCMP will handle all of this versioning, because I think that that's also part of the plan. Like right now we are talking about a very simple way of passing information from one parachain to another, but I think the next versions will be also handling versioning, just to allow more stable and robust communication.
Yeah, because like a follow-up to that was nothing would prevent a parachain that doesn't have that palette from like receiving an NFT. Because I guess like the handler wouldn't be there, and yeah, I think you'd be screwed.
Yeah.
And then we've got another question. So what exactly is the mechanism that XCMP message that's passing the XCMP message through the relay chain? And who will be the sender of that message on Parachain B?
So yeah, I'm not quite sure, like the mechanism. So yeah, it's going through the relay chain, but in that case, we were talking about this yesterday, Fernando and me, and yeah, it looks like it's going to a temporary local storage in there. But yeah, I'm not quite sure completely on how it's handled by the relay chain, this information.
Yeah, like I think what we came to is that basically you just like push these messages to a queue, like in your like local parachain storage, and then the handler will like read from storage and act on those messages, more or less.
Yeah. I mean, this is also version 0, so it's probably also not the best way on how it works.
Cool. Any other questions?
Yeah, if not, we can pass to Discord.
Yeah. Who will be the signer of the message on the receiver parachain?
So the signer of the message. I mean, right now it comes directly from the Parachain address. So yeah, the one that it's signing the message is the Parachain. So it, as you saw, it comes directly. You have the Parachain ID and you have also a Parachain address, and this is the source of the transaction.
So if the parachain can sign it, does that mean the parachain has a secret key somewhere? Or is it more on like Ethereum where smart contracts have an address, but they don't have a secret
Yeah, it's
key?
more like that. Yeah. They don't have a key. Yeah.
Yeah, weird. Cool. Yeah, I thought like that was pretty good. Like it's pretty exciting to see this stuff like actually come to life and being able to send NFTs across different chains. I'm excited to see what other people start like doing with this.
Yeah, me too. It's really cool just to explore different ideas. I mean, this idea of sending NFTs came to me a few days ago. So it was like, yeah, let's do it and let's just showcase the way to do it.
Yeah, cool. So yeah, if you have any more questions, I guess Ricardo will be on Discord, and I'm sure Bassi and some of the other people that are working more deeply in this are there as well to answer any of those technical questions.